Hello, mathematicians. Today we're going to be learning about slope-intercept form, and more specifically, we're going to learn how to write a linear equation from a table. So here I have a table where Celsius is represented by X and Fahrenheit is represented by Y. And in our table, we'll see the relationship between Celsius and Fahrenheit. Because as you know, if the temperature is 10 degrees Celsius, that does not make it 10 degrees Fahrenheit. So, if you also take a closer look at our table, you'll notice that our y-intercept is not here. I don't have an x value of 0. So for this table, not only do I need to find slope, but I need to find my y-intercept as well to write an equation in slope-intercept form. So, let's find our increase in y and our increase in x and find our slope by finding our rise over run. So from 50 to 68, the change here is an increase of 18. From 68 to 77, the increase here is by 9. From 77 to 86, this increases again by 9 degrees. From 86 to 104, this increases by 18 degrees. From 104 to 113 degrees, it increases by 9 degrees. So let's see how much our Celsius increases by. So from 10 to 20, our temperature increases by 10 degrees. And from 20 to 25, it increases by 5. From 25 to 30, it increases by another 5. From 30 to 40, increases by 10. From 40 to 45, it increases by 5. So here, from 50 to 60, it increased by 18 degrees Fahrenheit. And when it did that, it also increased by 10 degrees Celsius, which we could simplify this fraction. 18 divided by 2 is equal to 9, and 10 divided by 2 is equal to 5. And now if you notice here, my rate of change is completely simplified. And if we keep looking at our table, the next from 68 to 77, it increases by 9 degrees, and from 20 to 25 increases by 5 degrees, which is the same thing as 18 over 10, just simplified. So here I have my slope. So I know so far that y is equal to 9 over 5x plus, since I don't know my y-intercept, I'm going to put a variable here to represent that, which is b. So looking at our slope-intercept form here, I do have my slope, and here where we have y and x just represent a point. So I could pick 1050. I could pick 2068. I could pick any of these coordinates to be represented by y and x. So I'm going to pick my first coordinate here. So y in this case is 50 and x is 10. So by substituting in a coordinate, that helps us find our y-intercept, because now the only thing I'm solving for is b. So again, substitute your y and your x by a coordinate. So here I have 50 is equal to 9 times 10 is 90. If this is too difficult to look at, what you guys can do, because I have a fraction here, 9 over 5, I can rewrite the 10 as 10 over 1 because 10 is equivalent to 10 over 1. And here, by having two fractions, we could easily see numerator times numerator, denominator times denominator. 9 times 10 is 90. 5 times 1 is 5, so I have 90 over 5 plus b. So 50 is equal to 90 divided by 5 is 18, so is equal to 18 plus b. And now I just need to get b by itself. I need to isolate my variable, so I have to subtract by 18 for this to cancel out because they're inverse operations. And whatever I do on one side, I do on the other side. 50 minus 18 is 32. So my y-intercept is 32. So with all of that, I have my slope, which is 9 over 5. So this is m. And I have my y-intercept, which is b. So I could write my equation now in slope-intercept form. It's going to be y equals 9 over 5 x plus 32. And if we substitute any points into this equation, we'll get a true statement, and that's how we could double check if our slope and our y-intercept are correct. So here I have another table. Same thing. I don't have my y-intercept, so I'm going to have to find my slope and my y-intercept. And by doing so, let's start off by finding our slope. And so I'm going to start off with my change in y because that's my rise. So from 18 to 67, we have an increase of cost. So this is going up by $49. From 67 to 116, it's going up another $49. From 116 to 165, it goes up another $49. From 165 to 214, there's another increase of $49. And finally, from 214 to 263, there's another increase of $49. So here our cost is continuously increasing by 49. And our x value is the number of tickets, which is increasing by 4. And if we look throughout our table, it continues increasing by 4. Okay, so here I could write my slope as 49 over 4. And we could do two things here. So I can't simplify this fraction, but I could write it as a mixed number or as a decimal. So whatever is easiest for you to work with, because remember that we have to go back and find our y-intercept. So 49 over 4 is equal to 12 and 1/4, and it's also equal to 12 and 25.25. So the one that probably makes the most sense, and not that they don't make sense, but the one that probably looks the best for this equation is 12.25 because we are talking about money. So if we want to represent costs, this is probably the best way to do so. However, it's up to you. None of these two answers are incorrect. So with that being said, I know that y is going to equal 12 and 25/100ths, x plus b because I don't know my y-intercept. And again, you could pick any 2 points to substitute. I usually just like picking the smallest one because they're usually easier to work with, but it's really up to you because any coordinate will work. So here I'm going to use 1 and 18. So our y is 18. And our x is 1. So 18 is equal to 12 and 25/100ths times 1 plus b, which is simply 18 is equal to 12 and 25/100ths plus b. And if I want to isolate my variable, I'm going to have to subtract by both sides So I'm going to have to subtract 12 and 2500ths on both sides. And these are opposites, so they cancel out. $18 minus $12.25 is $5.75, which equals B. So our slope in this case is 12 and 2500ths, and our y-intercept is 5 and 7500ths. So here, y is equal to 12 and 2500ths, x plus 5 and 7500ths. So if we look at our table where x represents the number of tickets, we could see here that the cost of one ticket is $12.25 because we're going to multiply the number of tickets by our rate of change, and that's represented by our cost per ticket. And this $5.75 could represent maybe something like a convenience fee that you have to pay, or maybe an online fee for buying your tickets online. So this is some sort of fee that you only pay once. You're not going to pay this fee per ticket. And so this is my equation in slope-intercept form. Here in our next problem, our x is represented, our seconds is represented by x, and feet is represented by y. So in this sort of problem, something is probably decreasing, and then it ends up being below sea level because it gets into the negatives. So let's see how much our y is changing. So from 4 to 1, there's a decrease of 3. From 1 to 0, there's a decrease of 1. From 0 to -2, there's a decrease of 2. From -2 to -3, there's a decrease of 1. And from -3 to -5, there's a decrease of 2. And if we look at our x here, we have from 1 to 7, there's an increase of 6. From 7 to 9, there's an increase of 2. From 9 to 13, there's an increase of 4. From 13 to 15, there's an increase of 2. From 15 to 19, there's an increase of 4. So here, our rate of change, so it looks like our table is increasing by different amounts. So let's see, from 4 to 1, it decreased 3 feet in 6 seconds, which we can simplify. We could divide them both by 3, which equals to -1 feet over 6 divided by 3 is 2. And then if we look here, from 1 to 0, it decreases 1 over 2, which is the simplified form of this rate. And then here we have -2 and 4, which -2 over 4 is the same thing as -1 over 2. So our rate in this case is -1 over 2. So just like in the other problem, we don't have a y-intercept here. Don't get confused with this 0, because when y is 0, this is our x-intercept. So this is our x-intercept, not y. Okay? So in this case, we have y is equal to -1/2, x plus b, because we're not sure what it is. So again, pick a random point, a random coordinate. I usually like picking the first one. It does not really matter which one you select. You'll get the same answer no matter what. I'm going to select 1 and 4. So here y value is 4, and our x value is 1. Negative a half times 1 is just negative a half plus b. And if I want to isolate my variable, I'm going to add it by a half. These cancel out, add a half. So 4.5 is equal to b. I'm going to write that a little bit neater. So here I have my slope. Here I have my y-intercept. So y equals negative a half x plus 4.5. And in the context of this problem, so we started off at 4.5 feet, and as seconds go by, we're decreasing half a foot. So we're going down a foot every 2 seconds, or half a foot per second. All right, and here we have our last problem. X is weeks and y is pounds. So because our pounds are going down, we could assume that this person is losing weight. So from 217 to 202, there's a decrease of 15. From 202 to 199, there's a decrease of 3. From 199 to 187, there's a decrease of 12. From 187 to 157, there's a decrease of 30. From 157 to 154, there's a decrease of 3. And now let's look at our weeks. From 4 weeks to 24 weeks, there's an increase of 20. From 24 to 28, there's an increase of 4. From 28 to 44, there's an increase of 16. From 44 to 84, there's an increase of 40. From 84 to 88, there's an increase of 4. So our numbers look completely different, some of them. And so let's see what our rate of change is. So negative 15 over 20. So minus 15 pounds in 20 weeks. Which simplifies to negative 3 over 4. And here our next one is actually negative 3 over 4, which we know is equal to negative 15 over 20. And then here we have negative 12 over 16. So negative 12 over 16. If we divide each of these by 4, we also get negative 3 over 4. And then we have negative 30 over 40. So negative 30 over 40 also simplifies to negative 3 over 4. And then we have negative 3 over 4 again. So it's safe to assume that our rate of change is negative 3 over 4, which means that this person loses 3 pounds every 4 weeks. So y equals negative 3 over 4x plus b, because we're not quite sure what weight they started off at. So here I don't have 0 as an x value, so we do not know what weight they initially had. So in order to do so, we're going to pick a coordinate. I'm going to pick the first coordinate. I'm going to pick 4 and 217. So y is 217 and x is 4. And here we have equals negative 3 over 4 times 4 plus b. So 217 is equal to, here, negative 3 being divided by 4 and then multiplied by 4 actually cancels those two out. So 217 equals negative 3 plus b. If I want to isolate b, I need to do my inverse operation and add 3 on both sides. And 217 plus 3 is 220. These cancel out. So our y-intercept is 220, which is the weight that this person started off at. So I have negative 3 over 4 as my slope. I have 220 as my initial value, which is my y-intercept. So y equals negative 3 over 4x plus 220. And that's it.